Hey guys, Mr. Gran, 6.3 polynomial long division. So doing long division but with equations instead of numbers. So we're going to start out by using long division of numbers, and then we will parlay that into doing long division of polynomials. So a little review of how long division works with numbers. So if we're taking this, 26,439 divided by 5, the 5, that part goes right here, and then the number that's being divided, 26,439, goes here. All right, so now I'm looking, I can't divide 5 and 2, or 2 by 5 evenly, but I can divide 26 by 5, so that goes, 5 goes into 26 5 times, then we multiply 5 times 5, get 25 here, and subtract. 26 minus 25 is 1. Then we take that 4 and we bring it down to there. 14 divided by 5 is 2. 2 times 5 is 10. And what I should say is 5 goes into 14 twice, is what I should say. 14 minus 10 then is 4. Take the 3 and bring it all the way down like that. 5 goes into 43 8 times, so that goes up here. 8 times 5 is 40. Subtract it. 43 minus 40 is 3. Bring down the 9. And now 5 goes into 39 7 times. 7 times 5 is 35. I'm running out of room here. And if I subtract that, I get 4. Now this very last number, there's nothing more to divide, so what happens with that 4? If you think way back to elementary school, it is 5,287 remainder 4. And there's two ways that we could really write that. 5287 remainder 4, or we could write it as 5287 and 4 over 5 as a fraction. And this is going to be more like what we do when we're dividing polynomials. If there's a remainder, it's going to create a fraction on the end. All right, so if you want to pause the video, maybe rewind and rewatch if you need, and take a look at these two, and then you can unpause when you're ready. Okay, I'm just going to go like this to save a little ink. So 7 goes into 52 7 times. 7 times 7 is 49. Subtract that, it is 3. Bring down the 3. 7 goes into 33 4 times. 4 times 7 is 28. Subtract. 33 minus 28 is 5. Bring down the 5, the next 5. 7 goes into 55 7 times. 7 times 7 is 49. We're subtracting. 55 minus 49 is 6. And bring down that 2 all the way down here. 7 goes into 62 8 times. And 7 times 8 is 56. And so we've got a remainder then of 6. Did I do that right? Or do I feel like I screwed that up somewhere? 7 times 8, 56. No, that's good. Yeah, that's right. All right, so 74, 78 with a remainder of 6. All right, next one. Divide 6 into that. 6 goes into 8 once. 1 times 6 is 6. Subtract 2. Bring down the 7. 6 goes into 27 4 times. 4 times 6 is 24. Subtract. There's 3. 6 comes down here. 6 goes into 36 6 times. 6 times 6 is 36. So we have 0. Now the 3 comes down here. Now 3 doesn't go into, or 6 doesn't go into 3 evenly at all. So that gets a 0 above the 3, and then we'll bring the 2 down and we'll divide again. Or we could say, okay, 0 times 6 is 0, so 3 minus 0 is 3, and then bring the 2 down. It doesn't really matter. Then 32, 6 goes into 32 5 times. 5 times 6 is 30. And we've got a remainder of 2. Or we could put it as 2 over 6 and reduce the fraction, whatever. It doesn't really matter. All right, so how does this look for polynomials? So when we are dividing equations. Now, we're going to start out kind of light. This one is sort of a simpler one because we're dividing by a monomial, and I don't think this one is going to have a remainder on it. I think everything's going to divide evenly. So just kind of some baby steps here. Now, we're going to do the same thing that we did before. We're going to take that 5x and we're going to move it over here in front. And then in the division symbol, we're going to put the polynomial. Now, I do want to be careful that I make sure that I have all of the powers of x accounted for. It's not 100% necessary like with synthetic division, but it does help to use a placeholder if you have a missing power of x. So if we wanted to, we could throw a plus 0 in, but I'm going to say let's save that, and if we need to put a plus 0 there at the end, then we'll do that. Okay, so same idea as before. I want to start out by seeing how many times does 5x go into the first term. So how many times does 5x go into 20x to the fourth? 5 goes into 24 times, and x to the fourth divided by x is x cubed, right? Now I want to take this and I want to multiply it by 5x. So 4x cubed times 5x, 20x to the fourth, subtract it, and everything cancels out at 0. Then we can bring down the 45x cubed. I'm going to move that, get rid of that arrow. All right, so 45 divided by 5 is 9, and x cubed divided by x is x squared. Multiplying that again, I get 45x cubed because it divides evenly. When I subtract it, I get a 0. Next one would be the minus 30x squared. So 5x divided into negative 30x squared. Negative 30 divided by 5 is minus 6, and x squared divided by x is x. Multiply it through. It's negative 30x squared, and if we're subtracting a negative, it makes it a plus. So that went in evenly again. And now if we bring down the 45x, 45 divided by 5 is 9, and x divided by x is 1. So it's just 9 in this case. So for this one, no remainder here, and kind of a really nice, easy one. Now, it may seem a little bit odd the way that I wrote this out, because we kept ending up with a 0, but that's going to be really important for the more difficult ones. So there are other ways you could make it a big fraction with this on the bottom and just start canceling things, but really this is a good way to sort of practice it for what's coming up. But if you want to do it a different way, that's totally fine. All right, so let's try this one. Pause the video, and we'll see how this one goes. Okay, so I'm going to save a little ink there and just move the 6x over here. Now when I'm dividing, just to make it a little bit quicker in this one, I'm not going to write all the stuff down here because everything divides evenly for this one. So 36x cubed divided by 6x. 36 divided by 6 is 6. X cubed divided by x is x squared. Then 12 divided by 6 is 2, and x squared divided by x is just x. And then the last one, 60 divided by 6 is 10, and x divided by x is x. Is 1, so no x there. All right, and one more. Pause and try on your own. Now this one, we're dividing by a negative, so what happens when you divide a positive by a negative? What happens when you divide a negative by a negative? Be careful with your signs. All right, so negative 10x squared. I'll just kind of cross that out. All right, positive 120 divided by negative 10 is negative 12. X to the 8th divided by x squared is x to the 6th, right? You subtract the exponents. Negative 30 divided by negative 10 is a plus 3, right? It changes the sign, and 10 goes into 33 times. Then x to the 6th divided by x squared is x to the 4th. 160 divided by negative 10 is negative 16. X to the 5th divided by x squared, x cubed. And then negative 20 divided by negative 10 is a positive 2, so we'll make that plus 2. And x squared divided by x squared cancels out, so it's just 2 with no x's. All right, so now, what happens when we divide something bigger? So now we're dividing by a binomial. All right, so it's a little bit trickier. It's really the same idea, only the math, it's just one extra little thing with this. But it's really the same idea as long division, as any long division. Okay, so the first thing I'm going to do, I'm going to divide only the first term here by this first term. So what is x squared divided by x? It is just x. X squared over x, 1 cancels out, and it's just x. Now I'm going to take this x, and I'm going to multiply it by the entire thing here, the entire binomial, my divisor. So x times x is x squared. X times negative 3 is minus 3x, right? And I'm going to rewrite it underneath. And I'm writing it so that it lines up with the correct terms. We subtract at the next step. This is where we start losing some students. So the signs have to change, and the signs of everything have to change. So this becomes a minus x squared. This becomes minus negative 3x would be plus 3x. All right, now if I subtract this, x squared minus x squared is 0. So that should cancel out. If it doesn't cancel out, you did something wrong. 2x plus 3x is 5x. And now we bring down the next term. So 5x plus 6. And I repeat these steps. First term, my new first term, divided by my first term here. So 5x divided by x is plus 5. 5 times x minus 3 is 5x minus 15. So I just took that 5, right, and I multiplied it by the whole thing here. Same thing that you would do in any long division problem. 5 times this, 5x minus 15. I'm subtracting at this step. So this becomes a minus, this becomes a plus, right? The signs change. 5x minus 5x cancels out. 6 minus a negative 15 is the same as 6 plus 15 is 21. 21, I can't divide evenly by x, so this is now my remainder. With long division, that remainder looks like this. It's 21 over x minus 3. Just like in that very first long division one, I think it ended up being 4 over 5, a fraction at the end. Same thing here, only it's going to have a little plus in between it. So it's really the same thing as long division, except instead of like the tens place, the ones place, and then the remainder, it's the x's place, the constants place, and then the remainder. So it's sort of like each digit in those original ones represents a power of x. So if we went back to something like this, this would maybe be something like 5x to the 4th plus 2x cubed plus 3x squared plus 5x plus 2 divided by something. But the same patterns and the same rules apply. It just looks a little different. All right, now this one isn't set up. And we're also missing a power of x, so I'm going to throw a 0 in there as a placeholder. So when I rewrite this, it's going to be x minus 3 divided into x cubed plus 12x squared plus 0x minus 4. So again, not required that you do that, but a really good idea. All right, I'm dividing first term by first term. X cubed divided by x is x squared. Now I'm going to multiply that by both terms of the divisor. X squared times x is x cubed. X squared times negative 3 is minus 3x squared. I'm subtracting, so signs change. These cancel out. This becomes 15x squared. And I'm going to bring down the plus 0x as my placeholder. 15x squared divided by x is plus 15x. When I multiply 15x by both of these, I get 15x squared minus 45x minus plus, so I'm changing the signs. It doesn't always end up being a plus here, it just happens to be because we're minusing a negative each time. So those cancel out. This becomes 45x. We'll bring down the minus 4. This will be the last row, which is good because I'm running out of room. 45x divided by x is 45. And 45 times x minus 3 is 45x. 45 times 3 is 150 minus 15, which is 135. So minus 135 minus plus. So changing the signs again. 45x's cancel out. Negative 4 plus 135 is 131. That might be hard to see there. And so I'm going to take that and 131 over x minus 3 for my remainder. All right, one more to pause and then try on your own. This guy, it's already set up. Now this is one that you legitimately can't use synthetic division for because it's not x plus 1. The other ones you could, but we want to practice using long division. So start out first term by first term. 4x cubed divided by 2x is 2x squared. 2x squared multiplied by these two is 4x cubed. 2x times 1 is 2x squared. Subtracting, so now we're changing the sign, so this one becomes a minus 2x squared. Those two cancel out. 6 minus 2 is 4x squared. Bring down the 3x. Now we've got 4x squared divided by 2x is 2x. 2x times 2x is 4x squared. 2x times 1 is 2x. Change the signs because we're subtracting. Now we've got 4x squared cancels out. This becomes, 3x minus 2x is x. We could put a plus 0 over here and bring that down. It's not really necessary in this case. We really want the placeholders if there's a missing power of x in between somewhere, but this is 3, 2, 1, like there's nothing missing between the highest and the lowest, so we don't really need it. Okay, so x divided by 2x, that doesn't divide evenly, so I'm going to change this. That's going to be my remainder, and it's going to be x over 2x plus 1. All right, let your teachers know if you have any questions on this. This isn't the easiest topic to just jump right into, and especially if you're learning this from home. So like I say, email your teachers, get on some Google Meet with us, and we can try to work this out if you need additional help.